This is not really science. This is authority work. And my main question is, how could we achieve the safety of the food contact materials, which is basically promised to the consumers by legislation? Legislation says it is safe. We, as an authority, should make sure that this safety is really put into practice. I start with small deviation. Organic food is very successful, at least in Switzerland, I think everywhere. There is obviously a broad demand for it, and there are certainly many reasons for that. But one reason which I think should be important for us is the mistrust in safety. Many consumers don't trust the evaluation of the authorities for various reasons, but the nonlinear relationship mentioned this morning could be one. They would probably rather call it a homeopathic activity. No evaluation, official evaluation, takes such a thing into account. We always evaluate by a linear assumption. Okay, there is a mistrust, and in case of the pesticides, that's the organic, we have to say this is probably the best toxicological evaluation we have got in the food sector. Also, there is a large amount of control done throughout the chain and by authorities, so it's the best controlled part probably. Nonetheless, many consumers don't believe in it. If I try to get some numbers for the estimated exposure, very roughly, what usually is detected is 5 to perhaps 50 ppb of a substance, of a pesticide in the food. Can be more, but this is just the most common range. And from that, maybe the exposure is in the order of 10 micrograms per day. And this is for the sum of all pesticides together, which may be a nonsense, but just gives a dimension. So 10 micrograms per day. Now, if I go over to the food contact material, things look much worse. First of all, we know that the overall migration, gravimetrically determined, is commonly in the range of 5 to 30 milligrams per kilogram. And if I do such a rough estimate as before, then exposure is in the order of several milligrams per day. This is not all relevant, physiologically relevant, but perhaps half of that would be. So it remains in the range of milligrams per day, and this is then 100 to 1,000 times more than the exposure to the pesticides. So if people don't want to eat chemistry and buy organic materials, it is certainly not with the pesticides they should start. It's a complicated field also because I don't really know. I would guess that about 100,000 substances of a molecular mass below 1,000 Dalton exceeds the threshold of toxicological concern for unknown substances, which means they can be carcinogenics. Of these, well, that's a very rough estimate. Of these, not even 2,000 are properly evaluated, some of which have been evaluated long ago. Okay, so it's a very small part of it. The majority of all these substances has not even a name. They have not been identified. So if I go back to the pesticides for comparison, this is a lot more, perhaps 100 times more substances. The resources spent into it, however, are just the opposite. Much more is done for pesticides than for food packaging. Now you could say food contact materials are not pesticides or insecticides. So they're not meant to be toxic. Sure not. And it's, of course, not really possible to compare pesticides with migrating substances. However, chemistry doesn't distinguish that well. There is no green and red molecule. So yeah, the difference is smaller. And sure enough, in the migrating substances, there are also those which would not even be accepted as pesticides because they are too toxic. So it remains that the food contact material is a big gap in food safety. And this is my question: why should consumers trust in the safety of food contact materials if they don't trust in pesticides, or why should they trust more? Perhaps because it is not so easy to do without packaging material. I want to show a little bit a picture of the situation in terms of chromatography. My mind is chromatographically shaped, so for me peaks are pictures, and I don't know whether you can understand those. It's very difficult to create a picture what is the reality. Because if I talk to people, they say, well, that's all safe. Others say, well, how do you show? Okay, chromatography. This is a very simple case. This is a polypropylene just from the main manufacturer. It is not made to a film, it's not glued, there is no adhesive, no print, nothing. So it's just a crude polypropylene with a bit of an Irgophos as an antioxidant in it. This granulate was extracted with solvent. It was pre-separated by liquid chromatography into 6 fractions. And then what you see here are GC chromatograms, gas chromatograms. And every signal going up is a substance. The higher it is, the larger is the amount. I think this is the logic. Okay, if you go the classical way, polypropylene, you go into the list and you see for this, there are 2 substances which are listed. This is propylene. Okay, where is the propylene? Propylene is not here. It's anyway evaporated. Oh, easy job. Secondly, we have an additive. This is the Irgophos, and this forms this peak. Okay, finished. That's the common picture. However, if you look at it chromatographically, you see that there are many, many more peaks. Each peak is a substance. The next question is, of course, what is relevant? Is each of these peak of some relevance? Then you have to do some calculations, and I start again from the threshold of toxicological concern, which is 0.15 microgram per day. It's an exposure, it's not a concentration. If I just make it simple, assume 150 grams of food per day packed in such a material, if I assume that the thin film might be more or less completely extracted into the food, then this threshold corresponds to about 0.1 milligram per kilogram plastic, and this is about the peak here. Which means that every peak which is beyond this size is potentially relevant. And for us, as enforcement, we have to make sure that the producer ensures the safety of each of these. Okay, some are very trivial. These are fatty acids. Nobody will say this is toxic. For many more, this could also be shown quite easily, but the matter is to exclude that there is a really toxic component in it. Again, this is just a granulate, a crude polypropylene, nothing done it. As soon as you print it and so on, the chromatogram becomes more rich than this. That's an old chromatogram. This is now HPLC with fluorescence as a detection system, which can only detect bisphenolic components. Not bisphenol A necessarily, any component having that basic structure. You see lots of peaks, resolution is lower. This is liquid chromatography. This is from a can coating, and this is the only substance which has been properly evaluated. All the others, some have been identified as reaction products. For the most, we have no idea what it is. And if I go back to the same, what is relevant, then this peak here is such that probably it will be about 50 ppb in the food, which is, I could make a similar calculation as before, about 50 times more than the TTC. So peaks which are 50 times smaller than this one should be controlled. We have nothing of that. Paper and board. This is recycled paperboard, extracted, fractionated by HPLC into 1:7. These are the 7 fractions by gas chromatography. You see lots of peaks. This is the saturated mineral oil, that's the aromatic, and then we have a rich selection of more peaks. The chromatogram here shows small peaks. These peaks correspond to the size such that probably they will be about 10 ppb in the food. This is 0.1 milligram per kilogram in paperboard. This is about 10 times above the threshold of potential concern. So again, 10 times smaller peaks than these should be identified, or in some way the substance, the safety of the substance has to be ensured. Just to make a comparison, this is recycled paperboard and this is fresh fiber paperboard. This is all from somehow from the previous life of these fibers. The story, which is a bit more complicated, but perhaps gives a bit a taste of what the difficulties are. These are on coatings for water installations, domestic water supply systems. If the tubing, metal tubing, corrodes before it starts leaking, an elegant way is to remove the corroded parts and to coat it with such a material. One of the materials we tested was based on match, and these phenylcamines. These react at relatively low temperature, and that's why they are chosen. Of course, the mixture is more complicated, but these are the main components. How to show safety, how to make sure that the inhabitants of such a building are not slowly victims of chronic intoxication. There are 3 points to look at. First is after curing, when the coating is finished, is there something remaining that can migrate which could be toxic? The second, by aging, what is released from the polymer? So the chemical degradation, for example, by attack with chlorine or whatever. It's well known that these coatings age and they are changing. Then there are biofilms, there are microorganisms eating, but they don't eat it up completely. They release, what do they release? So the safety of all these 3 aspects should be demonstrated. We only looked at the first to see a bit how far can we do that and how difficult is it. As a rough indication, it is about 1 kilogram coating material per person in a building. A big building contains a lot, but also many people. So roughly 1 kilogram. It would be probably more for very rich people in a very big house, but that's their fault to have a big house. 1 kilogram, and we determined that in the coating we looked at very precisely, nearly 10% remained below 1000 Dalton. So the curing is by far not complete. Now, how do you proceed? You can do the analysis in water, and then again you go back to the TTC, and that means that the detection limit for this analysis would be 75 nanograms per liter of water. We tried all sorts of method of analysis. We synthesized components we thought that they may be formed, reaction products of course, nearly only reaction products. And well, it's difficult to detect these components because they degrade. They are not. It's not feasible by GC. So we determined that to get to this, we would have to extract that from water and reconcentrate these extracts 13,000 times. Every analyst knows this is by far not possible. For the phenalkamines, it is about 70,000 because detection is less sensitive. So roughly speaking, analysis in water is away from the threshold of relevance by a factor of 100 or 1,000. Well, I'm not speaking about the complexity. If you would do that in water, you would have lots of trouble with the components anyway in water. Another way would be to do the analysis in the extract of the material, saying that all the material of low molecular mass could be transferred to the water over 10 years. Maybe that's a bit exaggerated, but 10 years is a long time, so it's a lot of time for migration. We look at chronic toxicity, so it doesn't really matter whether it's leaching out relatively rapidly or over the full 10 years. Then we calculated on the amount introduced. We assumed that 1% of the water is really consumed, the rest goes through the toilet or whatever. And in this way, we saw that it would be 250 micrograms per day exposure of small molecular weight material. Now, you would have to analyze that, and again, up to the threshold level, which is the same 0.15 microgram per day. That means that we would have to check for components which represent 0.06% of this amount. Have you ever done that? That's impossible. I don't think there is a chromatographic techniques that would allow that. So this is far out of reach. You could also say, well, we avoid the analysis, we go directly to biotests. But you also know that it is not possible to detect such a small proportion in a total mixture, because you would have to introduce far too much of this extract into the vial. So the conclusion where we are today is that thousands of people are daily exposed to that. This is an experiment in a way. New buildings are treated that way, but there is hardly any information about safety. We don't know what is the composition of what is migrating. And first of all, we not even know how to do that. We are, at least in our hands, we were about a factor of 100 to 1,000 away from the level which could have ensured safety. Yeah, that's a picture of the situation. The main problem is what I call the ORPIs. This is an abbreviation for oligomers, reaction products, and impurities. I don't like the term NIOS. This is a silly excuse. Even if it's not intentional, it still needs to be safe. Sometimes people think that these impurities are traces or whatever, but if you go into the analysis of a complete migrate, and I have shown a bit, then you see that for reactive systems like coatings, this is the large majority, nearly 100% is such ORPI. For polyolefins, it is still in the order of clearly more than half. How to get that under control? Europe made a big effort in the 1970s and tried to get the control through the starting substances, listing authorized substances, and believing at that time toxicology was a bit different, that limiting the total by the overall migration limit would be sufficient to cover all the rest. Well, soon afterwards it was noted that this limit is far too high to exclude the presence of something toxic. Then a simple simulation was established to render the analysis easier. You have to think of the methods available at that time, which were very primitive. This was the concept then, and I think it is around 2005, perhaps a bit before, that people realized that this is not going to reach what is promised by legislation. The task cannot be fulfilled in this way. Very important was that around 2000, industry refused further collaboration. DG Sanko invited all the associations and asked whether they would accept a broadening of the scope of the plastic regulation or to do other specific regulation, and they all refused. We do it ourselves. So this is more or less the situation today. Of course, toxicology has developed, and there are endpoints which are much more sensitive, which makes everything much more difficult also. Also, there are far too many materials and substances are used to get it under control, so essentially it is nearly impossible. Well, nearly 5,000, no, more than 5,000 substances are used for printing inks alone, according to industry. Well, perhaps the most important step now is that the compliance work has to be documented, and there has to be a compliance declaration guaranteeing to the customer that the safety has been demonstrated. And the problem is that basically that's not possible. I don't think there are many food contact materials, perhaps there is not a single one for which compliance can really be declared. For all, there are such gaps as I have shown. So the silly situation is that somebody has to cheat. Either the declaration has no reasonable support, or there is a disclaimer which cheats the customer, says, well, I have done a lot, there is no, well, what is not in it, but finally it's you to have the guarantee. This is a silly situation which I think we should really avoid. Lying, cheating is not the way to go. But at the moment, everybody lives with this. There are artists creating very nice disclaimers. Nobody would notice. Sometimes retailers or brand owners are fed up and they want to have the paper signed they write themselves. And well, the supplier usually signs that, well knowing that it's not really supported, but also the one who has written the text probably knows that this is unrealistic. Enforcement also knows. Of course we know, but what should we do? And I think the worst is that media learned that this is a wonderful subject to make a scandal. Very easy. Everybody can make a bit of analysis and show that safety has not been shown. How do we get out of it? I don't know. But definitely we should start a discussion which is much broader than is today. So I'm proposing something, not because I'm sure that this is the best, but just to make the discussion a bit lively. First of all, we have to be more flexible and more pragmatic because the situation is as it is. We do not fulfill the expectation of the consumers. Well, the system which we have to think of has to make that the readily feasible compliance work is done as rapidly as possible. That must be done. Today, I think many would not even start because they say it's too complicated. Why should I dig and invest and then I get substances which cause me trouble? Why should I work to get trouble? So I better leave it as it is. for more difficult work, we have to admit that studies are needed. We have to find solutions. And I think for some things we won't get to the safety which is basically defined by IFSA in Europe. So we have to tolerate some gaps for a long time. So work plans, that's my proposal. First step is we have to get reality acceptable, or we have to accept that. This is not so easy. We as an authority, we are paid to enforce what legislation promises, and we can't. The brand owner or the retailer, he also has to accept that compliance declarations are incomplete, not really supported. So we have to make it acceptable. How could we make it acceptable? Well, I think we could do that if we say that this is a temporary problem. We haven't done it yet, and we have a work plan. We have ideas how we could go as far as reasonably feasible. So work plans to justify temporary acceptance of a situation which is not corresponding to the legal requirements. Okay, how to do that in more practice? First, I think these gaps, what I call gaps, so what is not done, has to be described. Well, so the producers of the material, can be an association or so, they have to define what are these gaps. Could be, well, oligomers or reaction products or something, and describe it. Gap descriptions. Basically, at the end of the process, all these gaps should be described by one of these descriptions. I imagine that these would be hundreds, perhaps also thousands of such gap descriptions. They have to be, to some extent, transparent. I think they should be registered somewhere. Well, don't know where. IFSA is usually the place to think of first. It has to be publicly available in as far as what is the general subject matter and who is behind it. Who is the owner of this description? I will show afterwards why this is necessary. Then a work plan has to be elaborated. So what is the chemistry which has to be investigated? How much could migrate? How could we tackle analytical problems? Also, what is the toxicological approach taken? I think for many things we need compromises because it's too complicated. Then we have to do some timelines to say up to when what has to be achieved. These work plans must be specific, realistic, not just clouds. That would be, yeah. Then these work plans have to be discussed, and there must be an authority with adequate competence to look at these work plans to answer three questions. First, is the subject matter really such that it merits a work plan? Because if somebody just didn't do very ordinary compliance work, it's not acceptable to establish a work plan. So it has to be of a certain level. Then, is the work plan really the best choice? The analytical approach, the toxicological approach, is the timeline acceptable? So, yeah. And the last question, is the safety assurance which is hoped for at the end of the process, is that satisfactory? If not, the material remains unacceptable and should be phased out. So it has to be discussed and sort of approved. And then, of course, you have to check whether the progress is as plant. The fifth step is now the paperwork the supply chain has to go through. If such a gap description is approved, then it can be used as a part in a compliance declaration. The compliance declaration means basically it is safe, has to be supported, and now either this is as today by concluded work, by data, by something, or it can be supported by a gap description. So to fill the gaps which have not been investigated to sufficient extent previously. So that's the new thing, to introduce that. Now, to get confidence, this has to be controlled. And for this control, it must be possible to check the work plan, or rather the gap description, through, for both. The supplier has to be checked. It must be that the retailer at the end knows that his supplier is part of the work plan, co-owner of the work plan. Also, authorities have to know that. And it has to be ensured that the progress is acceptable. Okay, I wanted to make some sort of a picture of where we are. I think we are very far from where we should be, and we need something better to go on, because the approach taken so far has not succeeded. It's not a silly one, but it's insufficient. We need something more. And I propose that for, I think always an idea is the best as long as there is no better one. We need to deblock the situation where everybody just cheats in a way. We have to find a way to get the situation acceptable, temporarily acceptable. The work plans are flexible. If we agree that this is feasible, that is probably not feasible or not feasible yet. This is a possibility. And very important, it has to be feasible on the basis of the existing legislation. EU cannot change legislation and say, well, safety has to be ensured if that is easy or if it doesn't cost anything, or it can't do that. The sentence is there and has to be respected. So legislation has to be the existing one. So it is the enforcement authorities who have to insist on the work, and it is industry responding by what I call the work plans. And we need risk assessment authorities capable of looking at these plans and evaluating them. This just as a proposal. Thank you.